Yeah.
All right, there we go. All right, so here we go. We're drawing pentane, and I'm going to show you the old way, which is this, of course, and then we're going to draw it the new way. All right, so that's pentane. So if we wanted to be lazy, one thing we could do is we could just write the carbons, right? So instead of writing it this way, an intermediate step, halfway to laziness, might look like that, right? But if we wanted to be even lazier, we know the things that are chained together are carbons, right? So really, we could just make lines, like a line, another line, another line, another line, and another line. And 5 lines together would be, or actually 4 lines, right? We just draw the bonds between the two, right? But that doesn't look right, because if I draw lines like that, they kind of connect together and make one line, and it doesn't make sense. So I could make little circles here if I wanted to, right? And that would give me like 5 carbons. Or I could just make the lines at different angles, and I could tell the difference. So I could do this. There's the bond between my first 2 carbons. Here's the bond between my second and third carbon. This is between my third and fourth. And this is between my fourth and fifth. So there's carbon number 1, 2, 3, 4, and 5. And that's how we're going to draw these. And all the hydrogens, you just assume they're there. There's 3 hydrogens here, there's 2 here, there's 2 here, there's 2 here, there's 2 here. So this is number 1, this is 1. 2, 2, 3, 3, 3, 4, 4, 5. So that's the lazy way. We're not even drawing carbons, all we're doing is drawing lines. And the rules are these. I'll give you the rules here. This would be skeletal structure. These are called skeletal structures. I think that's what they're called. Rule number 1. Both ends are carbons. So this is a carbon, one end, and this is a carbon on the other end. Rule number 2. Every, should I say corner or should I say point? What would make more sense? Point. Every point is a carbon. Rule number 3. All hydrogens are assumed to be there. So down here on my pentane, carbon number 1 has 3 hydrogens on it. I'm not writing because I know it's there. Carbon number 2 has 2 hydrogens on it. I know they're there, so I'm not writing them in. They're still there, I'm just not drawing them because I know that they're, I know there's 3 hydrogens here. Number 4, all other atoms are written. So anything that's not a carbon or a hydrogen, I'm going to draw a line, I'm going to write it in there like I did the old way. So to explain that, let's do a couple. Let's do something like, let's try 2 pentanol. Okay? This is going to have an oxygen on it somewhere, right? So you want me to draw it the old way or just the new way? Let's do both. Let's draw it the old way first. You need to just remember, make sure you know what it looks like. So pentanol is 5 carbons, and the number 2 carbon is going to have an oxygen on it. Right? So it doesn't really matter if you put it on top or bottom, right? And then we'll fill in the rest with hydrogens. So now we're going to draw it this way, the new way. Basically, we're going to draw pentane first. There's pentane. And then the number 2 carbon gets an oxygen and a hydrogen. So this will get O, and I'll put the hydrogen on here too. Even though I said hydrogens are implied, this one we're going to write on there because it comes off the oxygen. So that's pentanol. These two are the same thing.
Yeah, nitrogen on top and bottom.
No, I just put it whichever one points away because there's less space down here, so it kind of gets sloppy. Yeah, if you did it this way, for me that's fine. You can do that. That would have been perfectly fine. Just do a good single thing. All right, what else? All right, let's draw a couple more. I guess I'll change the number of carbons. We don't want to do 5 for everything. Let's do 1 butene. And let's do it the old way first. What is 1 butene? What am I going to draw here? How many carbons?
2.
4. Yeah, mixing up butene. Butene is going to be 4 carbons. And what's this going to have on it? Double bond on the number 1 carbon. So right there. Alright, so let's fill in the rest of the hydrogens. Okay. And the new way, you would just start out drawing butane first. So you put your pencil down, that's 1, 2, 3, 4. There's your butane.
So on the worksheet, do we have to do both ways?
Yes. And now between 1 and 2, there's a double bond, so we just put an extra line there. That's 1 butane. Let's do a cyclic one. And I think I might just give you all 10 alkanes here. Alright, so let's do this one, 1, 3, 5, cyclohexene. Okay, so this is benzene. So you've seen it already this way. Let's do it anyway. One hydrogen on every carbon. C225. Hey. Oh, I didn't do that. Actually, nobody's option. Oh, cool. All right, fine. All right. Attendance thing. All right, so to do our 6 carbons, we're just, again, every point is going to be a carbon. There's not going to be any ends because it's cyclic. So basically, this is number 1, 2, 3, 4, that's sloppy, 5. You're drawing a hexagon, right?
We have to draw like that?
Yeah, that's it. So there's your cyclohexane, right? And then the double bonds to make it 1, 3, 5 cyclohexene. And that's it. All the points are carbons, hydrogens aren't written. All right. Let's go ahead. I feel like I should do the 10 alkanes just to make sure we know how to draw them all. Yeah, no. I mean, yeah, that's the thing. I expect that you'll be able to draw, let's do it. Let's just go through and do these, right? So these ones you know how to do in the regular way. Methane, we'll do at least the first 5. Propane, yeah. Butane, pentane. Alright, so drawing these the new way, let me make some space here. Yeah, left enough room. What do you think ethane would look like? Yeah, ethane would just be a line, right? You could draw horizontal or diagonal, I don't care. Because there's just 2 endpoints for the 2 carbons, right? And what's propane going to look like? Well, it's got 3 carbons, right? So it's going to be 1, 2, 3. That's propane. Notice methane, with such a, this system implies so much that methane would just be a dot. It would be stupid to draw methane in a new way because there's nothing shown there. Even ethane's kind of silly. Butane is going to be that, 1, 2, 3, 4. There's your 4 carbons. Pentane. There's your 5 carbons. And let's do the other 5 too. We got hexane. 1, 2, 3, 4, 5, 6. If it confuses you, you can always put little circles at each corner and each end just so you can count them and remember them, right? Heptane. 1, 2, 3, 4, 5, 6, 7. And you should be able to get the formula from these, right? You can count the points and get your carbons. And 3 hydrogen, 2, 2, 2, 2, 2, 3. Add them all up and you get the formula. Or you can write it the old-fashioned way. Octane. 1, 2, 3, 4, 5, 6, 7, 8. Nonane. And decane. And from here, anything else that I give you, except for a cyclic, and you're going to start out just by drawing the alkane and then add on the other stuff. If it's cyclic, you're going to draw it in the shape of whatever it is, pentagon, hexagon, octagon, and so on. Questions? You good? All right.
So methane's nothing?
Methane would just be a dot, so it would be senseless to use this system to draw methane, It'd be like, telling an architect who draws buildings to draw 1 brick, just be a line on his paper. Doesn't make sense. I don't know if that was a good analogy.
Yeah, it kind of makes sense, but yeah, got it.
Oh, I'll think of something better.
We'll cut that part out.
Yeah, edit that out. Oh yeah, you can stop that now.
Yeah.
I kind of
Oh, sorry.
$2, please.
Watch the yellow video.